Hello friends, in this video I am going to explain AI basic concepts to understand the large language model and agentic AI. Let us say what is large language model. Large language model is powerful AI trained on massive text data. Here trained, this is the important keyword, and text data, this is the important keyword. Imagine this is a digital brain that has read various textbooks, various articles, websites, internet data, data sources, and additional information from internet and other sources. So it has gained lot of knowledge to understand human language and the relationship between the words, and then it is able to generate the response, and also it is able to create new content. So large language model is a neural network that is trained on text data to predict the sequence of next token. We will see what is neural network and what is training in my next video. Now let us see what is tokenization. Tokenization is breaking text into smaller and processable pieces. Before large language model understanding text, it should be broken into small tokens. A token is a word, or it can be a subword, or it can be even a character. For example, if we have a sentence like old is gold, old is gold, old and gold, these can be two words, and is can be one more token. So these are all three tokens. So now if we give a sentence like old is gold, it will be broken into three tokens. Sometimes it can be even subwords. I am eating lunch. Here, eat, ing, there can be two tokens. Eat is one token and ing is another token. That is the tokenization. Next, let us see what is vectorization. Vectorization is converting the tokens into numbers for the model. So now these are the tokens as we see here. These are various tokens, right? Now it is converting into vectors. So this is one vector, this is one vector, this is one vector. For example, in our example, old is gold. Old is one vector and gold is one vector. Similarly, if we have a word like apple, fruit, it can be one vector. Banana fruit, it can be another vector. But so two vectors are close to each other in this multi-dimensional space, if both the words has this similar meaning or close to same meaning. Fruits, apple and banana are related to fruits, so they are close to each other. Similarly, dog and cat are animals, so they are close to each other, but they have their own vector. Now let us see what is attention. Attention is focusing on the most important part of the input, because the input sentence can have multiple words, but in that there can be only few words are important. In the world is gold, three tokens, world is gold, but world and gold are important. Similarly, for example, what is the capital of France? Here, if we see what is the capital of capital of France, then right, what is the capital of France? Then France and capital are important words. See, the model pays more attention to those important words in the input. That is the attention mechanism. Then what is self-supervised learning? Self-supervised learning. For any training of model, there is a data required, but in this case, the labeling of data is not required. That means whenever we give an input sentence, the model predicts the next token even though it is not labeled. So in our case, old is gold, gold is masked, then the model predicts after gold is gold or gold is something else. But if it predicts correctly, then it will get the reward, and if it predicts wrong answer, then it will be penalized and the loss will be calculated, and again the input weights are updated during model training, pre-training. So self-supervised learning is learning from the unlabeled data by predicting what comes next. Next, what is transformer? Transformer is the core architecture behind any large language model. So in this case, the input is processed by this encoder and decoder, which are part of the transformer architecture, and finally it is able to generate the next token. We will see what is encoder and what is decoder in our next videos, but it is based on the attention mechanism. Attention is nothing but focusing on the most important parts of the input sentence, and this transformer process all the input words parallelly and then understands the relationship between various words to generate the new token. So this architecture process sequential text data to predict the next token. Large language model, especially this GPT, uses this architecture. Next, what is fine tuning? Fine tuning is nothing but adding a pre-trained model for a specific task. The pre-trained models such as GPT, they train on very generic data, so they give very generic response. But in organizations, when we are implementing the real world projects, we need to get accurate responses specific to our domain. For example, in healthcare industry, the model needs to be trained on the healthcare data to give the more accurate responses. So if our task is specific to that medical industry, then we will provide more data, more examples, labeled data to the model and train it to get the more accurate responses related to the medical tasks. So this is on the top of the pre-training model. We will train again with additional data specific to the domain or specific to our organization to get more accurate response for our specific task. But this is again long process and expensive process. So we will see shortly the other approach. What is few shot prompting? Few shot prompting is guiding the model with a small number of examples. During creation of the system prompt, we will provide various examples. The input prompt contains question and answer so that the model will understand, and if similar question comes from the user next time, it will predict the answer. In this case, 1, 2, 3 are provided as input in the prompt with the answer, then the model is able to provide the response for the similar question, fourth question, right? That is few shot prompting. Next, what is retrieval augment generation? Retrieval augment generation is enhancing responses by searching external knowledge. As shown in this picture, this is database external knowledge. So the model is able to retrieve the external knowledge and then use it as an additional context to provide the more accurate response. So this is very popular and commonly used in the industry in real world projects. These concepts are very important to understand for working in any AI project. I am going to provide more details and deep dive in next videos. Also, if you are interested to learn full details of these basic AI concepts as well as any real world projects, there is a website gurudev.ai. You can go through this guruai.dev. It provides in-depth understanding of various AI projects. You can work on the real world AI projects. Thank you.